Here we want to be able to evaluate the definite integral, and the integral that we have is x times the square root of x minus 1 times dx with a lower bound of 1 and an upper bound of 2. So the first thing we're going to do is we're going to use our u substitution, and then we're going to let u equal what's underneath the radical. So u is going to equal x minus 1. Okay. Now in step number 2, we're going to take the derivative of both sides. So we have du, and the derivative of x is 1, so we end up with dx because the derivative of minus 1 is 0. Now if you notice here, we can substitute dx for du, but then we got to figure out what do we substitute for x. So in order to substitute what we're going to substitute for x, we're going to have to solve for x in this first substitution. So we're going to add 1 to both sides. So therefore, u is going to equal, x will then equal u plus 1. So now let's go ahead and rewrite our original problem with a lower bound of 1, upper bound of 2. We have the square root of x minus 1 times x times dx. And what we're doing is now we're going to substitute each item. Okay, so we know that x minus 1 is u, so we know that we have the square root of u. And then we know that x is equal to u plus 1, so we're going to multiply that by u plus 1. And then we know that dx is equal to du. Okay, now we need to change our upper and lower bounds using the formula u, which is equal to x minus 1, where x is 2, so 2 minus 1 in the numerator in the upper bound, And then again here, u is equal to x minus 1. So that's going to be 1 minus 1. So let's go ahead and write that out. So 1 minus 1 in the lower bound becomes 0. 2 minus 1 in the upper bound becomes 1. We know that the square root of u is u to the 1/2. And then we're going to multiply that by u plus 1 du. Okay, so now what we're going to do is we're going to distribute before we take the antiderivative. So we're going to distribute the u to the 1/2 to both of those two terms. So when you multiply by the same base, you add your exponents. So we know that this exponent is 1, which is the same thing as 2 over 2. So u to the 1/2 times u to the 2/2 is adding those exponents. So we end up getting u to the 3 over 2. Plus u to the 1/2 times 1 is u to the 1/2, and that's times du. Okay, now we're going to go ahead and take the antiderivative. So if we take the antiderivative of u to the 3/2, it's 3/2 plus 1, which is 2 over 2. And then we write the same thing in the denominator, 3 over 2 plus 2 over 2. Plus we have u to the 1/2, which is plus 1, which is 2 over 2. And over here we have 1/2 plus 2 over 2. And then we have the upper and lower limits from 0 to 1. Okay, so now if we simplify that just a little further, we have u to the 5/2 divided by 5 over 2 plus u to the 3/2 divided by 3 over 2, going from 0 to 1. Now before we evaluate the limit, we need to multiply the numerator by the reciprocal of the denominator. So we have the following. We have 2/5 times u to the 5 over 2 plus 2/3 times u to the 3 over 2, and evaluating it from 0 to 1. So now let's go ahead and evaluate our upper and lower bounds. So for the first one, we have 2/5 times 1 to the 5 over 2 plus 2/3 times 1 to the 3/2. Now again, we're raising that to the power of that. And then minus the lower bound. So we have 2/5 times 0 to the 5 over 2 plus 2/3 times 0 to the power of 3 over 2. So if you notice on the right hand side, we multiply them both by 0. That means that this side is going to give us 0. So the only thing we need to calculate is the left side here. So what we end up having is 2/5 times 1 to any power is going to give us 1. So that's 2/5. Plus the same thing on this side, which is 2/3. And now we need to find the common denominator between 5 and 3, which is 15. 5 times 3 is 15, so 2 times 3 is 6. 3 times 5 is 15, so 2 times 5 is 10. So we end up getting the following, 16/15 as our result.